When you see someone with platinum blonde hair, silver highlights, or pastel-colored locks, it can seem like salon magic. One day their hair is dark, and the next it's pale blonde or ready for bright colors. But behind that transformation is something powerful: hair bleach. It's not just a beauty product, but a chemical process that removes natural pigment from each strand of hair. So what exactly is hair bleach and how does it work? Let's break down the chemistry behind it, right here on History of Simple Things. To understand how hair bleach works, we first need to understand why hair has color in the first place. Hair color comes from pigments called melanin, the same substance that gives color to human skin and eyes. There are two main types: eumelanin, responsible for black and brown shades; pheomelanin, responsible for red and yellow tones. Everyone has a different mixture of these pigments. A person with very dark hair has a high concentration of eumelanin, while someone with red or strawberry blonde hair has more pheomelanin. These pigments are stored inside the cortex, which is the thick middle layer of each hair strand. Think of the cortex as the core structure of the hair where both strength and color live. Because these pigments are locked inside the hair fiber, they aren't easy to remove. Water, shampoo, or sunlight alone won't completely erase them. That's where bleach comes in. Hair bleach works because it contains oxidizing chemicals that break apart pigment molecules. The most common ingredients are hydrogen peroxide, the oxidizing agent; persulfate salts, usually ammonium, potassium, or sodium persulfate; alkalizing agents, often ammonia or similar compounds. When these ingredients mix together, they create a powerful chemical reaction that attacks melanin. Hydrogen peroxide is the star of the process. It releases oxygen molecules that break down pigment molecules into smaller, colorless pieces. Persulfates help boost the strength of the reaction, allowing bleach to lighten hair much more dramatically than peroxide alone. Meanwhile, ammonia or other alkaline ingredients help open the hair cuticle, which is the outer protective layer of the hair strand. Once the cuticle opens, the bleach chemicals can travel inside the hair and reach the melanin stored in the cortex. That's when the real transformation begins. Hair bleaching works through a chemical process called oxidation. Inside the hair strand, melanin molecules absorb light in a way that creates visible color. But when hydrogen peroxide oxidizes those molecules, their structure changes. As the molecules break apart, they lose their ability to absorb light the same way. The result? The pigment becomes lighter and lighter until it eventually appears pale yellow or nearly colorless. But bleaching doesn't happen all at once. Hair actually passes through several color stages as pigment breaks down. Dark hair typically lightens in this order: black to dark brown to red to orange to yellow to pale yellow. That's why hair often looks orange or brassy during the bleaching process before it reaches blonde. The different pigments break down at different speeds. Eumelanin fades faster, while pheomelanin, the red and yellow pigment, is more stubborn and takes longer to destroy. One of the most common questions people ask is, why does bleached hair turn yellow instead of white? The answer lies in the pigments we mentioned earlier. Pheomelanin, the red-yellow pigment, is more chemically resistant than eumelanin. Even when bleach breaks down most pigments, traces of yellow pigment often remain. That leftover pigment gives bleached hair its pale yellow tone. To reach icy platinum or silver shades, stylists usually apply a toner after bleaching. Toners contain small amounts of dye that neutralize yellow tones. Purple toners are especially common because purple sits opposite yellow on the color wheel, helping cancel out brassiness. So bleaching removes the natural pigment, but toning helps fine-tune the final shade. Bleach is effective, but it's also harsh. Remember how ammonia opens the hair cuticle so bleach can enter the cortex? The same process can also weaken the hair's structure. Hair strands are made mostly of keratin, a strong protein that forms overlapping layers. When the cuticle opens repeatedly, those protective layers can become rough or lifted. During the bleaching process, some of the hair's natural oils and proteins are also lost. As a result, heavily bleached hair may become dry, brittle, frizzy, and more prone to breakage. This doesn't mean bleach always destroys hair. Professional stylists carefully control timing, chemical strength, and conditioning treatments to reduce damage. However, over-bleaching or repeated treatments can significantly weaken hair. That's why many experts recommend spacing out bleaching sessions and using moisturizing hair care afterward. Hair bleaching might seem like a modern beauty trend, but people have been trying to lighten their hair for thousands of years. In ancient civilizations like Greece and Rome, mixtures of vinegar, plant extracts, or ash were sometimes used to lighten hair under the sun. The real breakthrough came in the 19th century when scientists began experimenting with hydrogen peroxide, which later became the main ingredient in modern bleaching products. By the early 1900s, peroxide-based formulas made hair lightening more reliable and widely used in salons. Why bleached hair sometimes feels different. People often notice that bleached hair feels lighter, rougher, or even thicker than untreated hair. That happens because the bleaching process slightly changes the structure of the hair strand. When pigment molecules are removed, tiny gaps can remain in the hair cortex. Meanwhile, the lifted cuticle layers make the surface less smooth than before. This change in texture affects how hair reflects light, absorbs moisture, and responds to styling. Conditioners, hair masks, and protein treatments help restore some of the smoothness and flexibility lost during bleaching. Hair bleach might seem like a simple beauty product, but it's actually a mix of chemistry and biology at work. By opening the hair cuticle and breaking down melanin through oxidation, bleach can dramatically change a person's hair color. From ancient sun-lightening tricks to modern salon formulas, humans have spent centuries finding ways to transform hair color. So the next time you see someone go from jet black to platinum blonde, remember, it's not magic. It's chemistry working one strand at a time. Thank you for watching. If you have suggestions for our next video, feel free to share them in the comments below. We'll be sure to give you an acknowledgement for your contribution. Thank you for joining us on this journey through the history of simple things. Don't forget to like, subscribe, and stay tuned for more stories woven through the smallest details.